Welcome to all of you in Sankalpa Education Pratham classes. I am Sachin Patil, delivered lecture series on mechanical properties of fluids. Right now we are going with the Pascal's law. The statement of Pascal's law is here. First of all, we have to read the statement of Pascal's law. The pressure applied at any point of an enclosed fluid at rest is transmitted equally and undiminished to every point of the fluid and also on the wall of container provided that effect of gravity is neglected. What does it mean? First of all, pressure. When we apply a pressure on one point of the enclosed fluid, placed in a vessel, at that time the fluid at rest is transmitted equally. That means the force or the pressure which is applied at any one point, which is transmitted equally and undiminished. What is the undiminished? That means without a decreasing. There will be no any loss in that transmission of the pressure to every point of a fluid and also on the wall of container. That means with equally transmitted and without decreasing in the quantity of that applied pressure. It is transmitted to the all walls of container, where we does not consider the gravity effect. You just going with pressure, no consideration of the force acted by gravity is here. And right now we are going with the experimental proof of that Pascal's law is here. Once again I am repeating that consideration is here. When we apply the pressure enclosed fluid at any point, it is transmitted equally and without any loss every point in the fluid, and it is to the wall of container also it is transmitted what is the quantity of that pressure as it is. And experimental proof for this purpose, first of all we have to take the container is here, and this container is having 4 outlets. One outlet is here, one outlet is here, one outlet is here, and one outlet is here. That means 4 outlet at 4 places. Let us consider first outlet at point A, second outlet at point B, third outlet at point C, and fourth outlet at point D is here. And those outlets having different cross-sectional areas. Right now we have to consider here. Consider vessel with 4 arms A, B, C, D, fitted with a frictionless watertight piston filled with incompressible fluid. That means inside this vessel we have to fill it with incompressible fluid is there, and those are the nothing but watertight pistons are taken here and having a different cross-sectional areas. Area of cross sections of A, B, C, D be the area of cross section of first arm A having area A, second arm B having area 2A, third arm C having area 3A, and fourth arm D having area A divided by 2 is here, and respectively those are related to A, B, C, D. And let us consider F be the force on piston A. F be the force which is acting on piston A, and therefore according to definition of pressure exerted on the liquid, we have to apply pressure in this direction on that one, and at that time when we pressure applied to that one, it is it provides the outward pressure on those 3 arms, that means B, C, D, and you want to stop that arms. At that time you require different forces, that means 2F, 3F, and F divided by 2 is here. First of all, according to definition of pressure having the definition is force per unit surface area, and therefore according to that one, PA, that means pressure at point A, is nothing but F divided by A is here. And now we are going with the consideration of this one, and if it is observed that now it is observed that piston B, C, D are moving outward. outward. If we want to keep these three pistons that is BCD at BCD in original position, we require a force, and original position we require force 2F at 2F at B, 3F at C, 3F at C. I want to highlight those consideration after taking clearance of that one. 3F and F divided by 2 at D position, and according to that one we have to get the consideration of those pressures at the points BCD is here, and from this we will get the consideration related to that pressures indication. And here those are the forces which is required at a particular point, particular arm A, B, C, D is here, and according to that one pressure at or on B is PB. Let us consider it is a PB, and PB is equal to, what is the force acting at the B point is nothing but 2F, and what is the area of cross section, it is nothing but 2A is here, and therefore 2F divided by 2A, and it is nothing but F divided by A is here, F divided by A. Similarly pressure on C is PC is equal to where C is here, and the force acting at the point C is 3F, and area of cross section is 3A, and therefore 3F divided by 3A. 3 and 3 cancels here, and you will get the F divided by A. And on point D, pressure PD is equal to it is given as a consideration of PD is equal to, where you will get the consideration of force is F divided by 2, and area of cross section is A divided by 2, and therefore you will get the F divided by 2 divided by A divided by 2 cancel to each other, and you will get the F divided by A. What is seen from those 4 considerations? First of all, we have to going with PA is equal to F divided by A, PB is equal to F divided by A, PC is equal to F divided by A, and PD is equal to F divided by A. That means, that is PA is equal to PB is equal to PC is equal to PD. And here we apply the force at point A, and which is transmitted at the point B, C and D, because these 3 are forces which is transmitted due to force applied at point A, and therefore we can say that, or it indicates that the pressure applied on piston, the pressure applied on piston A is transmitted equally and undiminished to all parts of the fluid and wall of vessel. What is it mean? That means when we apply the force at any one point, that means if you want to apply the force here, I am considered the force is applied at point A, that means at arm A. At that time when we pushes the arm inside at the A with force F and having area of cross section is A, at that time pressure is created at point A, which is equally transmitted to the four arms, that means B, C and D here, and there will be a same pressure applied at that points without diminishing, means without decreasing in the value of the pressure which is generated at point A. And therefore at point B, at point C and at point D, all over these 3 points there will be a pressure is having the same quantity, that means F divided by A, F divided by A, F divided by A, and therefore PA, the pressure which is generated at point A, which is transmitted without losing its value and without diminishing, without decreasing to the point B, C, D. And this is nothing but your Pascal's law, and according to that statement you will get the consideration of when applied pressure applied at any point, that means we have to apply the force at point A, it generate a pressure P is equal to F divided by A, which is transmitted equally and undiminished, that means having equal quantity, that means it is transmitted at point B, at point C and at point D as it is undiminished, that means without decreasing and without decreasing every point of the liquid, that means it is transmitted to the every point without decreasing, and wall of container also, which is proved experimentally by using that vessel enclosed fluid with without incompressible fluid inside the vessel and providing 4 arms A, B, C, D. You will get the consideration of that theorem or of that law with the statement. You will get the pressure at B, pressure at C, pressure at D. It is same as that of pressure generated at point A, that means F divided by A, and therefore pressure applied on the piston A is transmitted equally and undiminished to the all parts of the fluid, and which is the proof of Pascal's law experimentally done here. If you like that video, please subscribe my channel and click on bell icon to get the next notification related to that lecture. Thank you.